Because this is sine x, okay, sine x, remember what we said the other day, sine x can't be changed. Okay, you can't make a sine x cos x. You can't change sine x, but you can change a cos square x. So we gotta get the same, we can't have a sine x and a cos square, okay, or a sine and a cos. We need to have one of the two. So we're going to change the cos square to 1 minus sine square, okay? So that's how you start. Make it 1 minus sine square x plus 11 sine x plus 1 equal to 0. So all we did is we changed the cos square to 1 minus sine square. Then when you multiply it in, you're going to have 3 minus 3 sine square x plus 11 sine x plus 1 equal to 0. And now, obviously now we can, the 3 and the 1, we can add them. 3 plus 1 is 4. And you get this negative 3 sine square still here. Negative 3 sine square x plus 11 sine x plus 4 equal to 0. So we're almost done with this part. It's almost in standard form. Okay, you just never want a negative. When you're working with squares, you never want a negative. So you change all the signs, and you're allowed to do that. We've spoken about it. So you can make it 3 sine square x plus, no, now it's going to be minus. It's minus 11 sine x minus 4 equal to 0. So when you get here, you don't want the negative, so you change the signs of all of them. You divide, basically you divide everything by negative 1, and then you get there. Now we can look for the factors. Now we can say, it's going to be 3 sine x and sine x, obviously to get to 3 sine squared, and then we're going to have to use negative 4 and plus 1. It's plus 1 sine x minus 12 gives you negative 11 sine x in the middle. Okay? You happy up to there? Now we can say, therefore, sine x is equal to negative 1 over 3, or sine x is equal to 4. Okay, so we get up to there. Is that fine up to there? So we're going to say, okay, I'll just put it at the top now, just to make some space. So now we're going to say, for this one, let's start at this one. This one is not applicable. You can't get a solution here, okay? There's no solution for this one, okay, because it's too high. I mean, if you think of the sine graph, the sine graph goes up to 1 and down to negative 1, up to 1. It'll never go up to 4, a normal sine graph. So it doesn't matter what you type in, any angle, you'll never get up to 4. So there's no solution for this one. Now let's look at this one now. Now it's negative, so it must be in the third and fourth quadrant. Okay, remember that's where sine is negative, the third and fourth quadrant. So we're going to use second function sine 1 over 3 without the negative. We just check what is sine to the power negative 1, or shift on a calculator sine 1 over 3, and you get 90.47. So we're going to say therefore x will be 180 plus 19.47, or x will be 360 minus 19.47. That's my two options. Third quadrant, 180 plus theta. Fourth quadrant, 360 minus theta. That's where it's negative, and it needs to be negative. And now we can just simplify this and add to 360 times n. So we're going to say therefore, for this first one, x will be 199.47 plus 360 times n element z, or x will be 360 minus 19.46, so it's 340.53 plus 360 times n element z. So that's our two general solutions. Okay? Now we still need to know x element negative 360 to 360. So now we're going to start looking at the specific solution. So we start by putting in 0 in the place of n, 1 in the place of n, negative 1 in the place of n. And we check which solutions will fit between negative 360 and 360. So when we substitute 0 and you get 199.47. You substitute 0 in here, you get 340.53. And you substitute negative 1 in here, 199.47 minus 360 gives you negative 160.53. And when you put negative 1 in here, for this one, you get negative 19.47. So there's your 4 options.